In this video, I'm going to give you some tips and tricks for the mini project that is about compound interest. Before we get started, I would definitely make sure you have your calculator with you so that you can do these calculations along as I'm doing them. So questions 1 and 2 would be a compound interest problem similar to what's in the notes. You have $3,000 you'd like to deposit into a savings account that earns 3.5% annual interest compounded monthly for 5 years. So we'd be asked to find the account balance after 5 years, and we're asked to round our answer to the nearest cent. So the compound interest formula is A is equal to P times 1 plus R over N to the NT, where A is the amount that's in the account at the end of the compounding period, P is the principal or the initial amount deposited, R is the annual interest rate expressed as a decimal, N is the number of compounding periods per year, and T is the number of years. So in this case, P is 3,000. R would be 0.035, so 3.5% as a decimal. Compounded monthly means 12 times a year, so there's 12 months in a year. And then T would be equal to 5. So if we plug all these in, over 12. So what I recommend doing, so you'll have 3,000 times 1 plus 0.035 over 12. Raised to the power of 12 times 5. For your calculator, I recommend doing 12 times 5 first, which gives us 60, and now we'll put the rest of it in. Okay, so we have 3,000 times 1 plus 0.035 divided by 12. Use the caret for exponent to the power of 60, and let me write down what we get. We get 3,572.8284, ... Okay. So rounding to the nearest cent, so if you go to McDonald's and something is $4.53, there's 2 places out to the right of the decimal for cents. It's also at the hundredths place, okay? So we're rounding this 2. We look next door. It's an 8, so this becomes $3,572.83. Okay. Question 3 and 4 will work a little bit differently, so let's go ahead and read a sample of what it will look like. You'd like to accrue $100,000, so you'd like to accrue $100,000 in an account 30 years from now by making a single deposit into an account that earns annual interest of 3% compounded quarterly. So we're still using the compound interest formula, but in this case, the amount you'd like to accrue is actually A, and the single deposit we're looking for is P. Okay, so T is 30, R is 0.03, and compounded quarterly means 4 times a year, so N is equal to 4. So let's substitute in everything. So we have 100,000 equals P times 1 plus R over N to the N times, N is 4, times T. Okay, so I still recommend doing the exponent first, so this is 120, but ultimately we're going to be solving for P. So what I would do first is to do this expression, the 1 plus 0.03 divided by 4 to the 120, and when you do this in your calculator, write out as many decimal places as it's showing, okay, to avoid any rounding errors. When it says round, you don't round until the very end of the problem. Okay, so this gives me, so I have 100,000 equals P times 2.451357,078. Okay, now to solve for P, notice P is being multiplied by 2.451357078. So I can divide both sides by this number. Okay, so 100,000. And I'm going to go to the next slide, and I get $40,793. Okay, and we're asked to round to the nearest cent again, so we go to the second decimal place or to the cents place. We look next door, that number is less than 5, so it stays the same. So in order to have $100,000 in an account that earns 3% annual interest compounded quarterly, 30 years from now, you would have to deposit $40,793.73. So for this type of problem, you're looking for P instead of A, and we were looking for A in the first couple of questions. Okay. Questions 5 and 6 are working a little bit differently. These are part percent whole type problems, so let's take a look. You have an account that has $100,000 that has an annual percentage rate of 3%, and you want to withdraw the interest each month. So what's happening is each month this is accruing some interest, and let's say you want to take it out. So you're almost withdrawing it as a source of income. So this is a part percent whole problem because we have our whole is our 100,000. Our percent we'll talk about in a minute, but it's given to us. And the part is what we're looking for, which is our interest that's accrued each month. Okay, now notice for our interest rate for R, we have an annual percentage of 3%, but we're withdrawing interest each month. So we have to be careful what we do with R here. So that 3%, in order to get the monthly interest, we have to divide it by 12 to figure out what's happening in a month. So R would be 0.03 divided by 12. Okay, and then we can use the part percent whole triangle back from unit 1. So interest is what we're looking for. Our rate is 0.03 over 12, and our whole is 100,000. Okay, so if two numbers are on the same level, we multiply. So we take 0.03 divided by 12 times 100,000. And this gives us 250. Okay, so for an account like this, if you're just letting the money sit there at an annual percentage rate of 3%, and you're taking interest out each month, so let's say you have 100,000 in at the beginning of January, it'll accrue $250 in interest, you'll take that out, so you'll still have 100,000 at the beginning of February. It'll accrue interest, you'll take that out, and so on and so forth. Another type of problem that you'll see in 5 and 6 is estimate to the nearest tenth of a percent the annual interest rate needed to be able to earn $450 per month in interest from this $100,000 account. So now what we're given is we're given the interest, so we're given the part. We still have our whole as 100,000, but we're looking for our annual interest rate, okay? But we still have per month to deal with. So when we do our part percent whole triangle, we can also think of it as, or there's another way to think of it. I'll do that next. So we have our part, which is 450, our whole, which is our 100,000, and then in this case, what we want it to equal to is our rate, our annual interest rate as a decimal, over 12. Okay, so something to keep in mind here is whole times percent equals part, or another way of looking at it, if we solve for percent, percent is equal to part over whole. Okay, so our percent, R over 12, is equal to our part, which is our interest, over the whole, which is 100,000. Okay, there's different ways to solve this. You can cross multiply, you can figure out what the right-hand side equals, multiply by 12, go on from there. If you cross multiply, you would get R times 100,000 equals 450 times 12, which would be 5,400. Okay, now we have to divide both sides. Oops, there's an R there. We have to divide both sides by 100,000. Okay, so R would be equal to 5,400 divided by 100,000. And remember that this gives us R as a decimal. To convert it to a percent, we move the decimal over 2 places to the right to give us 5.4%. Now, in this case, it worked out that this is to the nearest tenth of a percent, and the reason why is our last digit is in the tenths place. But let's say you get something like 0.078213. Okay, if we move this over 2 places, so you convert it to a decimal first, and then you would round. Okay, so convert it to a percent first and then round. So whenever you're rounding percents, convert to a percent first and then round.